Hello, wonderful people. My name is Janelle, and thank you for going on this journey with me. Are you feeling a little lost in the world of tech? Cloud computing giving you the blues? Programming languages are all Greek to you? Artificial intelligence making you question your own intelligence? Well, you've made it to the right place. Welcome to 6 weeks later, where together we will master information, one focus sprint at a time. If you're over 40 and ready to understand the digital world, you're in the right place. And as always, don't forget to like, share, and subscribe. Today, we are beginning our 6 weeks Kubernetes Sprint. We will be packing a lot of information in, but remember, we're in this together. You don't have to go at the same pace as me. If you want to split the lessons in half and take 12 weeks, that's great. If you want to speed through and do it in half of the time, that's also great. Learn at your own pace, take breaks, and congratulate yourself for wanting to start something new. Today, we're going to learn about containers and Docker. We're also going to go over the tools that you're going to need to install and use for the next 6 weeks. And yes, there will be homework. So what are containers? Containers divide an operating system in a way that allows you to securely run multiple applications. Imagine you're moving across country. You have furniture, books, clothes, and delicate items. If you just throw them all into the car, things will get messy, break, and be hard to unload. Now imagine using standardized shipping boxes. Each box is self-contained. Everything for one part of your move, for example, all of your kitchen items, goes into one box. Each shipping box is isolated. What's inside one box doesn't affect what's inside another. The boxes are also portable. Any truck, ship, or train that can carry a standard box can carry your box, no matter what's inside. And the boxes are always consistent. No matter where the box goes, the items inside are arranged the same way as when they left. Where does Docker fit in? Docker does the same thing for software. Instead of moving physical items, we're moving applications. A Docker container is like one of these standardized shipping boxes for your software. It packages your application code along with everything it needs to run, such as libraries, settings, and other programs, into a single, isolated, and portable unit. Docker containers were made popular by the company called Docker. While there are other container services available, Docker containers do come with built-in benefits. They offer portability. Have you ever heard a developer say, "It works on my machine," when a program doesn't work somewhere else? This happens because different computers have different setups. Docker solves this. Since the container includes everything the app needs, it will run exactly the same way on any computer that has Docker installed. It's like sending a self-contained mini computer. A Docker container can run on your laptop, on a server in your office, or on a cloud computing platform like Google Cloud, AWS, or Azure, anywhere Docker is installed. Docker containers also offer isolation. Each container is isolated from other containers and from your computer's main system. This means applications don't interfere with each other. If one container has a problem, it won't crash the other containers. Docker containers are also very efficient. Containers are very lightweight and start up quickly. They share the computer's core operating system, unlike virtual machines, which run a full operating system inside another. They also offer scalability, which is important for Kubernetes. Once you have your app in a container, it's very easy to make copies of it and run them all at the same time to handle more users. This is where Kubernetes really shines, but Docker makes the initial packaging easy. But how does Docker know how to package our containers? In our moving example, how does it know not to pack the dishes with the shoes? It starts with the instructions called a Dockerfile. This is a simple text file that contains a list of instructions on how to build a Docker image. Think of it as detailed assembly manual or recipe for your container. Let's look at an example Dockerfile. We start by telling the system we will be using an existing image and setting our working directory. We copy the image, run some commands, and tell it what commands should be run when the container starts. Following the instructions in the Dockerfile, we now have a package box called a Docker image. A Docker image is the read-only packaged version of your application and all of its dependencies built from a Docker file. It's like the sealed, ready-to-ship box itself. You can't change an image once it's built, but you can create many identical copies from it. Now that we have the package box, it's time to get it moving. A Docker container is a running instance of a Docker image. It's like taking a sealed shipping container, putting it on a truck, and starting its journey. Now it's active and doing its job. You can start, stop, pause, and delete containers. When you delete a container, it's gone, but the image or the blueprint remains, so you can always create new containers from it. Let's go over some essential Docker commands. You'll run these commands in your computer's terminal on Mac and Linux machines or PowerShell on Windows. Docker build reads your Docker file and creates a Docker image. -T stands for tag. This gives your image a name and a version. The dot at the end means look for the Docker file in the current folder. So always run this command from the folder where your Docker file is located. Docker run takes a Docker image and starts it up as a running container. The -P stands for publish or port mapping. This connects a port on your computer, the host port, to a port inside the container or container port. In your homework, this is how you access your web application running inside the container from your web browser. I like to think of these next set of commands as a Swiss Army knife. You will always use them and see that they are always handy. Docker PS shows you all the Docker containers that are currently running on your computer. Docker stop stops a running container. Docker RM deletes a container that is no longer running. Docker images shows you all the Docker images stored on your computer. Docker RMI deletes a Docker image from your computer. You must stop and remove all containers based on that image first. Let's briefly go over the tools we will be using. You will install these as part of your homework. Detailed instructions are provided in the Day 1 document. Docker Desktop. This is a user-friendly program that lets us create and manage our Docker containers. It also includes a mini Kubernetes system, which you will see written as K8s, otherwise known as K8s. kubectl is the remote control for your Kubernetes. It uses commands that will type into your computer's terminal. Visual Studio Code, or VS Code, is a powerful, free text editor specifically designed for writing computer code. We'll add extensions to make it understand Kubernetes better. Git helps you track all of your changes made to your code. It's an essential part of managing projects. GitHub is a website where you can store your Git projects online. It's great for sharing projects with others and for collaborating. We've come to the end of the lesson portion of Day 1. The main takeaways for today are: containers are isolated, portable packages for your applications. Docker files are the instructions to build images. Docker images are the package blueprints. And Docker containers are the running instances of the Docker images. Here's a general overview of today's homework. Detailed instructions are provided in the Day 1 document. You want to start by grabbing this document. It will walk you through installing the tools we talked about. You will then create a project folder with a small web application in it. You will walk through the steps of creating a Docker file, Docker image, and a Docker container. That concludes everything for Day 1. I want to thank you so much for joining me. Be sure to like, subscribe, and sign up for notifications so you can continue on this sprint with me.